The first of the chemical reaction types that we want to explore in this course are endothermic and exothermic reactions. And we'll cover these in just the next few minutes. It's interesting to look at the word itself, which might give you a little bit of a hint of what's happening in the reaction, in the chemical reaction. Endo usually means in. Exo means out. That's where the word exit comes from. Endo means in, exo out. Thermic is to do with temperature or heat. So when you think about it, endothermic must have something to do with meaning that heat goes in, or heat energy goes into the reaction, and an exothermic reaction means that heat goes out of the reaction, or heat is lost from a reaction. If you understand the nature of the word itself, it can help you to remember what the reaction is about. So let's have a close look at examples of how this will work. So first of all, an endothermic reaction. So in an endothermic reaction, you have your reactants and your products. For this reaction to take place, heat or heat energy must be put into the reaction. So heat must be taken out of the surroundings, usually out of the air surrounding something. So heat energy gets taken out of the surroundings and put into the reaction to make it happen. So energy has to be put in to make the products. Now just imagine what this might do, or how you would experience this. If heat energy is taken out of the air, because it has to go into the reaction, that would make the surrounding air, or water, the surrounding air would go cold. So if heat is taken out of the air, because heat has to be put into the chemical reaction to make it go, that means the air around the reaction would feel cold. It would go cold because air's been taken out of it. So this is an endothermic reaction, because heat is put into the reaction to make it go, and that takes heat out of the surrounding air or the water and makes it colder. An example of this, as quoted in the textbook, is something like ammonium nitrate. When mixed with water, makes various products, but what's interesting is that this is used in cold packs for medical application, because this reaction actually, when applied to the surface of a wound or a fracture or something like that, when this reaction takes place, it draws heat out of the surrounding area and puts it into the reaction and leaves the area feeling cold. So these cold packs actually involve chemical reactions going on inside to suck heat or take heat out of the surrounding air. So they're endothermic reactions. Exothermic reactions are the opposite. So in an exothermic reaction, heat is lost. So as the reactants undergo a chemical reaction to make products, heat is actually lost from the reaction. So the surrounding air or water, as I'm sure you can guess, will feel hotter. It will get warmer. So heat is released from the reaction, and this is an exothermic reaction. Remember, heat energy out. So heat is lost from the reaction. One of the examples using the chemical reactions you did in the laboratory of this, perhaps you can think of the exothermic reaction you did, but it involved mixing copper chloride, so a blue liquid, with aluminium foil, so aluminium atoms, and that reacted to make, I think you identified that some copper appeared out of the reaction, and quite possibly some aluminium chloride was made. But what was interesting is that the temperature in the beaker went up in some cases by 10 or 20 degrees Celsius. So heat was lost from the reaction. Heat was made in the reaction and heated up the surrounding liquid. And this was actually, you measured this using a data logger, a temperature probe on your computer. And you could actually see that the products were warming up. They were getting hotter than they were at the beginning. So this is an exothermic reaction, as heat was made and therefore lost into the surrounding liquid. So that's what an exothermic reaction means.